Hello and good afternoon everyone. So today's we are 11th week of problem solving session. So today's classes we are solving some rearrangement problem. So before start today's problem solving session, I briefly introduced about myself. So my name is Pavir Maiti. I am a PMRF student from Aijan Mohali, and the course you have taken the name was Symmetry, Stereochemistry and Application, and course instructor Professor Angshuman Roy Chaudhary. So earlier classes we are talking about some substitution reaction, elimination reactions also, and before that we have talking about that some stereochemistry problem. I will solve that. So today's classes we are solving some reaction mechanism, how it will be happen. So we are mainly focusing on some name reaction rearrangement. So first I start with that Bergman rearrangement. So what is Bergman rearrangement? So Bergman rearrangement. So first step is that from a carbonyl we are making an oxime, and after if you add heat and acid and heat, and you are getting this product where this one of this methyl group are substituted by this OH. So OH become leaving group and your methyl is substituted. So how this rearrangement going on? So I follow in that next step. So what we are find out that so in these reactions what bonds are key bonds are formed, that is that CN bond. So this bond are formed CO bond and CO pi bond, CO sigma and CO pi, and key bonds broken, that NO bond like this bond, and bond broken of CC bond and CN pi bond, that double bond are broken. So how this reaction is going on? So in Bergman rearrangements, the step one is that protonation step. So I am going to this step only. So first step is the protonation step. So how the protonation? So this is the only that the first step how it will be happen. So first step is the in ketone if we add hydroxylamine. So hydroxylamine. So if the ketone, so ketone have that oxygen have the del negative charge. So it will have a del negative, and your so this carbon become little bit del positive. So any nucleophile come attack this position. So your hydroxylamine where the nitrogen have the lone pair, so it will be attack. So when it will be attacked, so this carbonyl double bond will be broken, so it becomes CO minus. And so now this your NH2OH, so NH2OH it's become N plus OH H2. So what will happen? So again that your OH minus which are present in this solution, so it will abstract one photon like this, so it will be become NHOH, and your this O minus also abstract photon from the water, so it will become OH. So now your lone pair again come back, so it become the double bond again. So earlier that C double bond broke and you are making new double bond, that is the C double bond N. So now C double bond N come back, and here now your OH is a leaving group, so it will be comes out. So now we have that product like this NOH, and there will be one proton and become plus. To remove that proton, so you have the OH minus which comes out after deprotonation. So OH minus take the proton, here again come back to water, so but ultimately you are from there oxime. So the ketone to oxime reaction, first step is the ketone to oxime reaction. Then next the Bergman rearrangement. The Bergman rearrangement how it is happened. So in presence of acid, so this have the your oxime. So in presence of acid what will happen? So this is your OH, so which have that lone pair, so it can take photon from that acid, and acid easily lose that electron, so it become OH2. So now your OH2 is a leaving group, so it will comes out. So now it will be become, so now this 1 2 3 4 5 6. So now if you think this your 1 2 bond is broke, and it will be become a 6-member ring. So if in this position, if other methyl group and um, any group are present, then that will be broke. So it will be broke from this side also, or this side also. So ultimately you are increasing the, so first your member is a 6-member ring, now it will be 7-member ring, and one is that your nitrogen. So again what will happen, so this will be a protonate, so your water will become, so here what will happen, so that methyl, so methyl is rearrangement here when your water will be comes out, so that I will show it later. So now what will happen, so first I will show this example, then we will come back here. So then what will happen, then water which will be protonated this position, that carbocation, so if it is protonated this become OH, then acid will take one proton, so it will become NOH. Then what will happen, so again it will be C double bond O, again prompt, so and it will be protonated, so ultimately you are getting the NH, so ultimately you are from the amide. So in that Bregman arrangement, first from a ketone you can form that oxime, and from that oxime you are from that amide. So for this reaction how it will be happen, so if you show this reaction, so first step is that easy step where you are from like this your carbonyl group, and if you are adding NH2H, so what will happen, so your nitrogen have the lone pair, so it will be attack your this carbonyl, so you are forming like this. So this is your carbonyl which become now O minus, and you have this NH2, sorry, H2OH. So now N become that more than 3 substitute, so it will be become positive, and this methyl already is there. So now what will happen, so your water taken one photon and it will become NHOH. So water protonate this one, that will become OH, and one OH minus taken one proton, and you are forming NHOH, so it will become NH and OH. So now you have that OH minus present, So it will taken this proton. So now it will happen. So this nitrogen have also the lone pair. So it will become double bond again. So double bond is more stable than the single bond. So what will happen? So you are become C double bond N from, and this will be taken out. So you have now this will be double bond N. So it will be become N plus. Then after one proton, which will take up by this OH minus. So it will become double bond NOH like this. Now, if you add acid and heat it, any acid RCOOH and heat, so it will form your amide. So how it will be happen? So amide formation will be like this. So first, this NOH, this OH become protonated, and you are getting, this will be your N, and if your OH is protonated, so it will become OH2 plus, and which is a leaving group, so it will become comes out, so it will be OH2 plus, so it will be comes out. Now when it will be comes out, so then your this become positive, so which will be not favorable, so it will be rearrange this. So ultimately forming, sorry, so now this will be our double bond N, which have now methyl, and here it will become the positive charge. So now what will happen? So you have that water medium, so which is act as a nucleophile now, and it will be attack this cation, carbocation. So you are getting the product like this. This will be your N, So this will become OH. So now it will come back, and this will be taken one proton. So ultimately you will get the product will be like this. So you have double bond O and NH. This become NH and this become methyl. So this overall reaction is Bergman rearrangement. So Bergman rearrangement, what will happen? So first from a ketone to you form oxime, and from oxime you are forming the amide. So these are the step. First your carbonyl is attacked by the sidoxylamine and you are become oxime, and then oxime this OH leaving group will be comes out, and again you are become from the carbocation, and this carbocation attacked by that water and you form that carbonyl back again, but your NOH is replaced by H, so you are become amide product. So next we are see that Hofmann and Cartier's rearrangement. So from Hofmann and Cartier's rearrangement, what we are getting? So from amide we are getting the amine. So how it will be happen? We are showing that example. So first that bromination. So you are from the isocyanate, and after that you remove that carbon dioxide. You are forming that amine. So Cartier, so that this is that Cartier's rearrangement. So in the Cartier's rearrangement from acyl azide carbamate, so you are forming the carbamate. So how it will be happen? So first that acyl azide formation. So there will be RC double bond O and N3 plus, and when you eat it, so your nitrogen will comes out. So you are forming that isocyanate like this intermediate, which is unstable, and when you are add water, so it will be become amine, and when you are adding some alcohol, so it will be become carbamate. So how this rearrangement is going on? So setting up that Hofmann reaction, so first the formation of N-bromo amide. So first your amide is brominated by bromine, and it will be become RNH2Br, and then one photon taken by that OH minus, so it will become N bromide. So now your bromide is a leaving group. Now what will happen? So so when it will be removed, so you will become the positive charge here. So now your this bond is break and it will be attached here. So you are forming that RNCO. First is the NaCO, then you are working. Ultimately forming that RnCO. Then from RnCO, if we heat it, so your nitrogen will be taken out and you are forming that isocyanate. And if you add the water, you are forming the amide. So how it will be happened? So first step is that, so like this your some CONH2 amide group, where if you add that acid OH minus, so it will be taken one proton and you will become RCOO NH and Br bromide. Now it will be NH minus act as new profile and it will be attack the bromide and you are forming N bromo amide. So now in bromo amide, so you have already that base. So in basic medium, so this proton will be taken out and you are forming N minus Br. So now this R will be rearrangement here and it will be become RnCO. Now if you add water, so water will attack this carbonyl and so you are forming that OH O minus. So this will be O minus. So O minus again come back here and it will become C double bond OH. So then your this lone pair again come back and it will be liberated as CO2 and you are forming this molecule that amine. So from primary amide to amine. So amide 2 first is the formation of N bromide. So from N bromide, then N bromide, then this here that alkyl group which is rearrangement and come back here and you have to form that isocyanate and after that isocyanate if you add the water, so it will water will be attack in this carbonyl, so it will become CO minus OH and after liberation of CO2, so it will be forming only RNH2. So similar type of reaction can be formed rearrangement. So like in this rearrangement, so if you have that NOH, so it will become, if you add acid, so it will become NOH2. So your phenyl between phenyl and methyl which will be rearranged. So phenyl will be rearranged and after this attack, so you are forming amide. So from oxime to amide, earlier we have shown. So from oxime to amide, what should we remember? So you remember that when there will be N will be positive, so what group will becomes? So that's that methyl migrate or phenyl. So it will be N plus cation, carbocation, and we have the phenyl which have that more electron cloud as compared to methyl, so phenyl will be migrate. So that's that you have to remember. The next is that mechanism of benzylic acid rearrangement. So benzylic acid rearrangement, so what we are getting from this two carbonyl, where after addition of acid, so this will be rearrangement and we are forming one is acid and one is alcohol. So what will happen? So if you add that OH minus, the base. So base will be attack your carbonyl and it will become OH O minus. Then your phenyl is come here, migrate, and if you are forming ultimately C double OH O minus. So after protonation, so it will become OH C double OH. One is alcohol. So from two carbonyl, so one is alcohol and one is acid. Now is the Cope and Claisen rearrangement. So in Cope and Claisen rearrangement, what we are getting? So have the rearrangement happened in presence of heat, and the rearrangement we are getting different product. So like when you have in that 1,5 diene, when you have add heat, so your substitute product earlier is there. So now what will happen? So if heat it, so now your double bond making new bond here, and so and this bond will be broke. So you are ultimately get the product would be like this. And what is the Claisen rearrangement? So Claisen rearrangement in presence of allyl vinyl ether. So from this allyl vinyl ether, so if you heat it, so what will happen? So this double bond new bond is formed. So and this will be broke. So you are forming the unsaturated aldehyde group. So Claisen rearrangement is a reaction of allyl vinyl ether that proceeds through a concerted mechanism similar to that cope, and you are getting a alpha, beta, gamma, delta. So you are forming a gamma delta unsaturated aldehyde. So the Claisen condensation result in a new CO pi bond at the expense of CC pi bond, and when which gives it a strong driving force about 20 kilocalorie per mole. So you have the C double bond O, which is much stronger as compared to the CC bond. So this will happen. So from Claisen rearrangement, what we are getting? So from allyl vinyl ether to forming a delta gamma unsaturated product. So how this scope rearrangement happened? So the mechanistic study. So what bonds are formed and what bonds are broke. So first this C1 C6 bond is formed new, and your C3 C4 bond is broke, and your double bond broke C2 C3 which will be formed, and C4 C5 pi bond is formed, and C1 C2 pi bond is broke, and C5 C6 pi bond is broke. So how the mechanism? So the mechanism will be transition state, and all of these are going to a concerted mechanism. So concerted pericyclic reaction, symmetropic rearrangement, and you are forming the product like this. And cope arrangement will favor the more substituted alkene. So if you have more substituted monosubstituted alkene 15 and disubstituted alkene more stable. So you have the monosubstituted alkene. From monosubstituted alkene to you are forming a disubstituted alkene, which will be more stable. So which will be favor reaction for this Cobb rearrangement. So Clayton rearrangement. So from that allyl vinyl ether, you are forming that alpha delta unsaturated aldehyde. So what forms are, so your C1 C2 pi bond broke, C5 C6 pi bond ridge broke. You have C2 double bond O, the new bond ridge formed, and C4 O which will be broke. How? So similar type of reaction it will be happen if you have the allyl vinyl ether and if you heat it. So what will we get? So this is the example of some aromatic group. So which help with this O. So what will happen? So this new bond will be formed. So this is become C double bond O and it will be broke. So ultimately you are getting that non-aromatic product. But this is not stable, so it will be tautomerized to restore the aromaticity. So when you have that carbonyl which is taken one proton by this, so it will become here and it will become O minus, and from this it will be taken this proton, so this will become C double bond O, and you are ultimately you are getting a final aromatic product. So now one example, if you get here, so if you in this reaction if we add that OH minus and water and heat it, so what will happen? So this OH minus taken one proton from this, so this will become positive negative charge. So now this negative charge will be attacked here and ultimately you are forming this which is the carbonyl and PHME, and this will be your methyl already there. So now this atom will be attacked here, it will become carbonyl again and it will be become C double OH. Now this negative charge will come here and will be protonated by this water, and ultimately you are getting from that you are forming that acid. So from a ketone, so you are forming the acid where this methyl group are rearranged to here. So only this methyl group are rearranged to here and this will be become COOH. So today's is up to this. So in today's classes what we are seeing. So first one is that Bagman rearrangement. So in Bagman rearrangement what we are getting. So from first step is that from a carbonyl you are from the formation of oxime, then from oxime to you are getting amide. So how this rearrangement is going on from, so only this NH2OH and carbonyl, only that water will be come out and you are forming a new bond C double bond N. Then after that your one methyl group is rearranged, you form again that carbonyl back and you are getting the amide product. So in the next reaction we are talking about Hofmann and Cartier's rearrangement. So Cartier's rearrangement, Hofmann degradation and Cartier's rearrangement will be like this: from amine to amide, where the Cartier's rearrangement come from that acyl azide to you are forming that amine. So how it will be going on? First that you are from an bromoamide, then your n bromoamide, bromide leaving group is taken out, and you are from that isocyanate, and from this isocyanate, if the carbon dioxide will be comes out, so you are forming ultimately that amine. So now that benzylic rearrangement, so in benzylic rearrangement, if you add that base into a dicarbonyl system, so what will happen? So one phenyl group is rearranged, and also you are forming one acid, one of carbon will become acid and another become that alcohol. Similar like a oxime reaction, so what will be from oxime, if you form amide, oxime to amide, what should be um, what bond will be break, so that will be depend on which will be stabilize this nitrogen positive charge, so that phenyl will be more chance to stabilize this, so it will be become, so this phenyl will be comes here, so you are forming amide but your phenyl will be broke and forming new bond with that amide side. Then we're talking about the Cope rearrangement. So Cope rearrangement is a reactions where only new double bond are formed and some double bond are broke, and in close I, on the basis of Cope rearrangement we can form that Claisen product. From Claisen product, from allyl vinyl ether 2 we are getting the product gamma delta unsaturated aldehyde. So this is that rearrangement reaction, how it will form. Then we talk about some rearrangement on the ketone side where the leaving group is already present. So if you have any doubt, now you can tell. All of you understand. So if you not, then you can feel free to ask your any doubt to by my email. So if you have doubt like this reaction, that how this aromatic to non-aromatic product form and then aromaticized. So you know that any aromatic, the electrons are feel free to delocalize everywhere. So if you delocalized your electron into the system, so that will be more stable. So in non-aromatic, so electrons are not delocalized. So somewhere the electron density is high, somewhere electron density is low. And your any molecule or any system cannot like this. So if you comes that aromatic, how it will be restore the aromaticity. So the restoration of aromaticity by tautomerization. So first this proton will be take up this your carbonyl and again you become a minus. So now it will be tautomerized again and restore that final aromatic product. So here we have to remember, so like that one CC bond to C double bond C bond are broken and new C double bond O and CC bond is formed. So like the strength of energy you are forming like C double bond O and C double bond C is the new bond formed and you are broken, which is the less energy as compared to that C double bond C to C double bond C and C double bond C. So this is comparable, these two, but C double bond O which is at new high energy as compared to that C double bond C. So these reactions are energetically favorable or thermodynamically favorable reaction. If all of you understand, so I close today's classes. Thank you for your attention. save it.